Hey Techno Studs, let's give this a try again. So now we know about the bridge protocol data units, a little more about the process, and have a little more information. Let's try one of those examples again and see if we can fill this in. I'm going to add an extra switch to this, but do the same thing. Pause the video once I show you the outline, the layout. Pause the video, take a look at it, try to figure it out, and then we'll cover it together. Pause the video and see if you can come up with the answer yourself. Let's see if you've come up with the right answer. The first thing that we want to do is we want to elect the root bridge. What is the root bridge? And we base that off of the priority and then the extended system ID and then the MAC address. So let's take a look at the priorities first and see if we can hone in on one device here. So when we take a look at the priority, I see here of 4,096, which I can see 28,672 is less than, and we're looking at for the lowest. So that could be a contender right there. And then we see a couple defaults, which is 32,768. So we've got those in there. 768. So we can see that this is actually the lowest priority, and we don't even need to look at MAC addresses. If we were to look at MAC addresses, because all of the priorities were set the same, we would also see that this has the lowest MAC address as well. So this switch right here, we'll call this switch 4, is the root bridge. So we'll call this 1, 2, 3, and 4. So switch 4 is the root bridge here. All right, next we need to calculate the root path cost to the root bridge. All right, so from switch 2, what would this link to switch 2 would be a cost of 19, and same thing, or excuse me, it would be a cost of 4. So let's put 4 in there. So there's a cost of 4 there and a cost of 4 there. This link right here to the root bridge is 10 gigabits per second. So that's 2 and 2 right there. All right, from this switch right here to this switch right here, that's 10 gigabits per second. So that's 2 plus the 4. So this would be 6 to get there and 6. And then to come down this direction, this is a 1 gigabit per second. So that is a cost of 4 plus the 2. So this is 6 and 6. All right, so there we have it. So now we have, for switch 1, we've got 4 equal cost routes right there. So the next thing we need to do is we need to elect root ports. What are going to be the root ports? What is going to want to be communicated to? So for switch 2, let's take a look at it. We take a look at all 4 of these lines that on switch 2, and we can see that 2 of them have a cost of 6 to get around to this root bridge, and 2 of them have the cost of 4. So it's going to be one of the smaller costs of 4 that we see over here. So let's choose one of those. So it's going to either be 043 or 044. When it comes to we're either looking at the lowest cost to the bridge, or we're looking at the lowest sender bridge ID. In this case, the sender for both of these links is the same switch, so it's the same thing. So now we're going to have to revert to the lowest port ID. So if these are both set to the default port ID, then what's being sent across here is a 047 and 048. It's going to choose the lowest, so 047. So this right here is going to be the root port for switch 2. All right, let's take the same thing for switch 3. We go and take a look at this. The cost to go around this way, looks like the cost to go all the way around is actually going to be this link right here, which is 1 gigabit per second, which is a cost of 4 plus another cost of 6. So it's actually going to be 10 to go around in that direction right there. Okay, so it's going to be 10 to get that way. It's definitely going to prefer this 2 going this way in this direction right here, so across 045 or 46. Now, since it's the same cost of 2, it takes a look at the sender bridge ID, which happens to be the same. So it's because it's coming from the same switch. And so now it has to look at the port that it's sending on. So 045 and 046, provided that they're the same priority, it's going to choose 045. And this is going to be a root port right here. So we'll call that a root port for switch 3. All right, next we look at switch 1, and we have looks like it's even whether it goes this way, it's going to be 6 and 6, or this way, which is going to be 6 and 6. So the next step is that we have to look at the bridge ID. And so which one is lower? And we see this is set to 40,960, and this is 32,768. So the lower bridge ID is this way, so it's going to send it in one of these 2 links over here. So it's going to choose one of these now because of that, and now we need that tiebreaker. By the way, just a side note, the reason why this is important that it chooses the lowest bridge ID next is because let's say this switch 4 goes offline, then what will happen is this one will probably become the root bridge next. And so now it's already established that connection, and it doesn't need to do any other changes. It will just start sending things now to this new switch. So that's the reason why that's the next step when choosing a root port. Okay, so it's chosen either 045 or 46, and the next, since we need the tiebreaker for that, we need the port ID. So we have 045 and 046, it's going to choose 045 because that's the lower one. So now this is the other root port that it's going to send on. All right. So now we have a root port for each of the non-root bridges. And so now what we have to do is we have to elect designated ports. And what's going to win is going to be the closest to the root bridge. And the closest to the root bridge on this link is going to be obviously the root bridge itself. So we're going to mark both these with a D for designated port and both these for designated port because it's going to be, bring this back. There we go, we got D on each of those. In fact, actually what I'm going to do is I'm going to change the color here because it's getting a little bit cloudy. Maybe we'll do an orange here. So maybe mark that with a D, 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 D. Okay. All right. So now the designated ports for the rest of these links. So here, let's tackle these 2 links up here, which is the designated side, whatever's closest to the root bridge. So this is a gigabit per second, and it's a cost of 4. Versus the other side is going to be a cost of 6 to go around the other way. So these are going to be the designated ports on this side right here. And then for these 2 links on this side, the last 2 links that we have, if it goes around this way, it's going to be a total of 6, it looks like, and if it goes around this way, it's going to be a total of 2. So these are going to be the designated ports on this side. So let's mark those with D's right there. All right. Next, now that we've got the designated port, we can get to what we really want to get to, which is, okay, which ones are we going to shut down? So let me use a red X for that. And which ones are we going to shut down? If this is the root port right here, we're going to shut the other one down. So I'll put an X on that one right there. All right. Now we've got the root port here on switch 1. So the other one is going to be shut down, and I'll put an X right there. And then also these other 2 right here are going to be shut down. I shouldn't use the term shut down. It's actually going to go into a blocking state. So those are going to be our non-designated ports or our alternate ports. So, and then same thing, I look at this, the root port, and the only one that's not done anything with is this 046. So there you have it. So now we have everything marked on these switches and what they're going to be. So that is the answer for this example 2.